Greatest to least. Did you find it? Lane.
The one is 1600.
Yes, and how do we know that's the greatest?
Because it's the only one that has a one.
In the
One place.
in the ones place, yes. What's next? What's next? Finley. 6/10, and how do we know that's next? Okay. What comes third then? Ezra. 1600s, and what is last? What is last, Ezra? 600. Number 2, we have 7 nines, and we're getting rid of 5 nines. What do we have left? What do we have left? 2 nines. Number 3, what was important as we took a look at our subtraction here? What was important? Or number 2, I'm sorry, number 2, no, 3. Oh, it is addition. Sorry. It's addition. Yeah. When we line up the decimal point, what does it help us do?
It helps us keep the like hundreds and tens and thousands in order.
Yeah. Keeps all our place values lined up. Ezra, what did you get for your sum?
20 and 8900.
Yes, 20 and 8900. Number 4, what type of angle is the first angle? What type of angle is the first angle? Right. What type of angle is the second angle, Abby? Acute. Are they congruent? Are they congruent? Okay, what does it mean to be congruent? What does it mean to be congruent? That's symmetrical. What does it mean to be congruent? Yeah, they're equal. Exactly the same. Is a right angle the same as an acute angle? No. So are they congruent? They are not. What is 927 in lowest term? Not 3 nines. That gets it lower, but that is not the lowest. Eduardo? 1/3. 1/3. Number 6. What is the quotient?
16.
Not 16. Not 16,000. Did you have 1 0 and a 16? How many zeros did you have? 16 10,000. 16 10,000. Number 7, you multiply. What do you get for your product here? 9/20. Is 9/20 in lowest terms? 9/20 in lowest terms? 9/20 in lowest terms? Yes, it is. Number 8, what's the greatest common factor of 2 and 10? Valerie? It is not 5. It is 2. It is 2. And number 9, the ratio of 3 of 5 as a fraction. As a fraction. 3/5. And number 10, what is the formula for the area of a rectangle? Formula for the area of a rectangle.
8 equals 1,000.
Oh, that would be a triangle. We want a rectangle.
1 times 8.
Nope, nope.
2 times 12.
The formula for the area of a rectangle.
A equals W times L.
And typically we say length times width instead of width times length. In this case, what is our length? What is our length? Our length is 12. What is our width? What? 2. Therefore, what is the area of this particular rectangle? 24, and we need a label. Square centimeters.
What's the symbol between the 84 and the
This is an L. Okay. Okay. It's a cursive L because L, the not cursive, looks like a 1, so we do a cursive L. Okay. Questions? All right, get that recorded, please. Take a look at our assignment next, please. On 437, number 2 was 2/9 times 3. 2/9 times 3. I had some of you on Friday go, there aren't any ninths over here. And that's right, there aren't. So I would not have chosen that as one of my pictures to do. Okay? Instead, we could do 2/9. And we are multiplying it by what? We're multiplying it by what? 3. So it'd be 3 over 1. When we multiply across, we get 6 over 9. Is that in lowest terms? No. What can we divide those 6 and 9 by? 3. So the greatest common factor is 3. Your final answer would be 2/3. 2/3. Now, number 3. 4/5 multiplied by 10. We've got 10 groups of 4/5. Come up, right? All right. Okay. So now we're trying to fill out whole amounts, right? Okay. So I'm going to do the shortcut of it just to save time. Let me grab one there. Grab another one there. Grab another one there. And there. And there. There. And there. Which gave us 1, 2, 3, 4, 5, 6, 7, 8, right?
Mm-hmm.
And that would prove the 8, correct? Okay. Questions on that?
Mm-hmm.
All right. So do we understand the picture business?
Yeah.
Okay. And you would have shown the arithmetic. 4 fifths times 10 over 1 equals 40 over 5. And 40 divided by 5 equals 8. Yes?
Mm-hmm.
Okay. Questions on that? Okay. All right. So number 4, you would have done 9 groups of 3/4 and then filled in whole amounts. Yes? And you would have gotten 6 whole amounts with 3/4 left over. If you showed the arithmetic, you would have had 27 over 4, which would have given you 6 3/4. Number 5, you would have had 8 groups of 5/6. Filling in whole amounts, you would have gotten 6 with 2/3 left over. If you had done the arithmetic, you would have had 40 over 6, which reduces down to 6 2/3. Questions on that? Anybody? Anybody need to see any more pictures or see the problem written out? Number 6, you would have had 7 groups of 1/2. You would have filled in whole amounts, giving you 3 with a half left over, so 3 1/2. If you had done the arithmetic, you would have had 7 over 1 times 1/2, which gives you 7 halves. And in your division, you would have gotten 3 1/2. Questions on that one? Number 7, you would have had 6 groups of 2/5. Combining them into whole groups, you would have had 2 2/5. Doing the arithmetic, you would have had 12/5, which gives you 2 2/5 as well. Questions on number 7? Number 8, you would have had 9 groups of 2/3. Filling in whole amounts, you would have come up with 6 whole amounts. If you did the arithmetic, it would have been 18/3. And do your division, you still get 6. Number 9, you'd have 9 groups of 3/10. Filling in whole amounts, you would have 2 7/10. If you did the arithmetic, you would have had 27/10 or 2 7/10. Questions on any of that? Or 2 through 9? Number 10, you get 4 1/2 yards. Any questions on that? Number 11, 10 gallons. Any questions on that? Yes, Ezra? Ezra, I can't hear you. What number are you on? 10? 4 1/2 yards? Did you do a picture method or the numbers only? Did you do 6 times 3/4? So 6 over 1 times 3/4? Did you do that?
Yeah.
So you get 18 divided by 4? Did you do 18 divided by 4, Ezra?
Oh, I missed that part.
Okay. Is that enough?
Yeah.
Okay. On 438, number 1 is 1/2 of a box. Any questions on it? Number 2 is 30 minutes. Any questions on it? Number 3, I would have done 600 divided by 30 is 20 minutes. Or no, just 20, I'm sorry, 20. No label there. Number 4, you would add the 3/4 and the 2/3 to get 1 5/12 yards. Any questions on that one? Number 5, (12 3/4 miles. Any questions on that? Yes. 4 was 1 5/12 yards. Any questions on 5? Number 6, you're dividing by 100. What happens to the decimal point when you divide by 100?
What happens to the decimal point?
Does it move right or left? Left. How many places? 2 to the left, making it 25 hundredths, and the label is pounds. Questions? Questions? Anybody? Alrighty.
I got anything.
We have multiplied whole numbers and fractions. We've taken a look at that a couple different ways. We've talked about how to find like 1/2 of a third by using pictures. We're going to take a look at that again. And we're just going to take a look also at multiplying a fraction by a fraction without models today as well. Let's turn our books to page 439, please. 439. Okay, so take a look at modeling our fractions. We've done this before. So, if we want to find 2/3 of 3/4, 2/3 of 3/4, okay? We've talked about how to do this before. 2/3 and 3/4. We first need which there, the 2/3 or the 3/4? If we want 2/3 of the 3/4. If I want 2/3 of the 3/4, what do I need there first? I need the 3/4 there first. Because if I want part of something, I need the something there, don't I? If I want part of the cake better be there first, right? Okay? So if I want part of the 3/4, I need the 3/4 there first, right? That makes sense? Okay? Now, one way we can do this is we could use paper and fold it, right? Or we can just divide up our paper. Can we just divide up our paper rather than fold our paper? Would that work for you guys? Okay. So if we have a piece of paper, okay, if we want it to be in fourths, we could divide it into 4 equal parts that way, correct? Correct? Okay? That is the same as taking this piece of paper here and dividing it into fourths that way, right? Everybody understand that? Okay? And if I want 3/4 of it, I shade in 3 of the sections, right? 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 So we've done that on paper, right? So whether we have a physical piece of paper or we can draw it on paper is the same, right? Boom, they're the same, right? Okay? But now I want 2/3 of what I shaded in, right? So I can take the physical piece of paper and make it in thirds, right? Or I can just draw thirds up there, right? And let me tell you, drawing the thirds up there is a whole lot easier than dividing it into thirds, right? You guys have said over what is exactly thirds do now. So if I turn my paper like that, do you see the thirds easily? Okay. So if I go like that, my thirds are now in green, right? Okay. So if I shade in my 2 out of my 3, right? I'm going to shade in 2 out of my 3, but I really only need to shade in what's already red, right? Because that's all I'm talking about, right? I want 2/3 of that 3/4. Does that make sense? I want 2/3 of what was already red. 2/3 of the 3/4. The 3/4 is what's in red. The 3/4 is from here to here, right? Yes? So I'm really not looking at that part of the paper anymore, right? I'm only looking at this part of the paper, right? Okay? And I want 2/3 of that. So if I want 2/3 of that, I shade in that much of it, right? Yes? Or I can turn it that way and it matches up, right? Okay? But if I open it back up to its original piece, like that, okay? All right? I got this amount of the entire rectangle shaded in, right? So the reason I need my entire rectangle is because I need to know what size these really are. Does that make sense? This is one piece out of how many in the rectangle? One piece out of how many in the rectangle? Look at your rectangle. It's one piece out of how many, Piper?
12.
One piece out of 12. It's one piece out of 12. Right? Does that make sense? Okay? Does that make sense? Now the question is, I only wanted 2/3 of the 3/4, right? That's all I wanted. I didn't want all 12 twelfths, right? So I really only want this section right here. I want that piece, that piece, that piece, that piece, that piece, and that piece. How many pieces did I want of the entire rectangle? 6 out of the 12. I wanted 6 twelfths, which is actually
1/2.
1/2. Does that make sense? Okay? Yes?
I thought you said you wouldn't use that other side of the rectangle.
We only need that to know what size our pieces are. Does that make sense? But we don't need it to shade it in. Does that make sense? Okay? So do you understand why we don't need it for shading purposes after we've got our 3/4?
Yeah.
But we need it for what part of the rectangle is actually talked about. Okay? Does that make sense? Okay? Questions on that? Yes?
Isn't it just the same as putting
We don't need to make it the same denominator. Okay? All right? I tend to shy away from circles because circles are hard to get equal pieces in. That makes sense? Okay? Let's go down here and take a look at number 1. 3/5 times 1/3. 3/5 times 1/3. Do I need the 1/3 or do I need the 3/5 first?
no 1/3.
1/3. So when I look this way, I can see thirds. So I'm going to shade in my 1/3. All right. And then I want this going the other way, right?
Mm-hmm.
And how many of those do I want?
3.
3 of them. 1, 2, 3, right? How many total pieces have I shaded in both ways? 1, 2, 3 out of how many total pieces in the rectangle? Out of how many total pieces in the rectangle? 15. Okay? Does that make sense? Okay? So here we go with a circle. We need the 3/5 first, and they graciously divided it up into fifths for us. And they've shaded in 3 of them, right? Okay, so that came first. We now need 2/3 of each of those pieces. So we need to divide each of those pieces into thirds, right? And we need to shade in 2 of them. And here's where it just gets ugly. We can't really see it, can we? It's hard to see, and that's why I don't like circles. It's always harder to see it, right?
Mm-hmm.
Okay? So we have to go back, and we have to use a different color. Okay? Now, how many pieces have been filled in?
6.
No, how many pieces have been filled in? Look, how many pieces did we fill in?
6.
Hence why I don't like circles either. You can't sell it. How many pieces are double colored?
3.
Are we done coloring? No, because we didn't do 2/3 of all of the pieces yet, did we? How many pieces are filled in? How many pieces are double colored?
3.
How many pieces are double colored here?
2.
How many are double colored here? How many here? For a total of 6. Now here's the hard question. If the pizza were cut up into all equal pieces, how many pieces would there be? 15, because we would have to cut these up into equal pieces also. And there's why it's hard to see on a circle. You have to remember to keep cutting all your pieces up. Does that make sense? Okay? I don't like doing circles with you guys because you guys don't really see it.
Yeah.
Not easy to
It's on the
see.
homework too.
Okay? That's why rectangles are easier to see. Okay? If you did 2/3 of 3/5 in a rectangle, 3/5, we divided into 5 equal sections. And shade in how many?
2.
We want 2/3 of that. We divided into how many equal sections? How many?
2.
And shade in how many of them? How many of them are double colored?
6.
6 out of how many equal sections on the rectangle? Isn't that much easier to see than this circle? Why I don't like circles. You guys can't see it very easily. Okay? Now, how many of you see this is not in lowest terms? Oh! What can we divide those 6 and 15 by, Jonathan? Yeah, the common factor is 3. What is our lowest terms here? 2/5. Okay. You should have your book open taking notes. Any questions on that? Yes.
So if we have if there's a circle, can we do the rectangle?
I would not use circles. I would use rectangles. I would do rectangles. Circles to me are Way too confusing for you
Okay,
guys.
so we can go rectangle.
I would use rectangles. Even if they give you a circle, I would draw a rectangle.
So there's a
Yeah.
on the height.
Yeah, I would redraw a rectangle. Because I don't think you guys, first off, there's not enough space to do it properly. Second off, I don't think you guys truly understand circles enough to get your space in there to do it. I would draw a rectangle. Ezra, do you really want me to hear you? Thank you.
Times the
Well, it's called multiply.
multiply.
Oh yeah, you see it. You see it.
Multiply the numerator
Oh, you see it, don't you?
and the other numerator.
You see it.
Numerator and the other numerator.
Oh my goodness, you see it.
As the model.
You see it, don't you? Don't you?
I've been doing that on the last minute.
You see that. Let's take a look at number 3. 2/3 times 1/5. What would we draw first? 1/5. Shaded 1. How do we show 2/3 of that? How many are double shaded? Out of how many total? All right.
Okay, that's easy.
Now let's take a look at why what Ezra said will work. Well, first off, how do we get our 15? Well, we had 5 that way and 3 that way, and 5 by 3 gave us our 15, right? Right? How did we get our 2? Well, we had 2 this way and 1 this, whoops, actually 2 this way, sorry. Let me redo that. We had 2 here, oh, come on, Tim. Come back, Jimmy. 2 this way and 1 that way, right? The 2 times 1 that we needed? Yes, no? You see that?
Mm-hmm.
We needed 2 of those and 1 of those, right? Do you see it? Okay, that's why that works. Okay? Is this in lowest terms? Okay. So as we take a look at number 4, half times 5, 6. I need 5 of those and 1 of those for total. 1 times 5 is?
5.
I have 6 of those and 2 of those for total of? 5 twelfths. Okay? But why did that work that way? Because in my picture, I have 5 6. I had 6 rows that way. I need 1/2. I had 2 rows that way. 6 times 2 for a total of 12 boxes, right? Yes? Okay. I needed half of those, right? I needed 1 of those, right? And I needed 5 of those. I needed 1 times 5, right? 1 row of 5. Does that make sense? That's why that all works.
And on the other one, I saw that the 1 times 2 to get to 2, and then the 5 times 2 to get to 15.
Questions on that? I highly recommend using like either pen and pencil, two colored pencils, so that you can easily see it, rather than pencil on pencil. Okay? Questions? Yes, Ezra. You will have to understand models. Okay? You have to understand the model. Yeah, but you have to prove the model. Okay? Because one of the fifth grade standards is being able to prove you understand the model. Okay? So being able to draw the picture to prove it is going to be important. Okay? Yes. That's next. Okay? The assignment on page 443. In 3 through 6. If we look at that 3 through 6, there are 4 problems there. That means 4 drawings. That's it. 4 drawings. That's not hard to do, is it? Okay. And then 7 and 8 you don't have to do drawings for. Okay? Does that make sense? It's due on Wednesday. Assessment topic. Add and subtract fractions and mixed numbers. Compare fractions. Multiply decimals. Let me make sure there's nothing else. I'm sure in our having to switch things around 500 different times for the snow days. That's a matter of fact, it is the wrong answer. Yeah, that sounds like last week. You did last week. All right. There is some adding, subtraction of fraction mixed numbers. So it's multiplying fractions. Sorry. Not very much like last week. Model fraction multiplication. And then we've done a lot of work with polygons, you know, like talk about parallel sides, how many sides it has, you know what I'm talking about?
Mhm.
So like, I have 4 sides, so therefore I am a quadrilateral. I have 4 sides with 4 right angles, therefore I am a rectangle. Yes? No? We've been working on that quite a bit. Okay. All right. One thing, bringing around cookies. Make sure you only touch the one that you are taking. Everybody did not get a cookie yet. All right. Did you want one? You guys will also have to evaluate an expression. Evaluate an expression. I'm sorry, I didn't go down far enough, sorry. Can you pull that open up, please?
I am moving badly. I'm gonna keep them up.
You know what that means?
Oh, those? You get those again. Oh, I love those. Yeah, see, they're fun.
What's wrong with you?
If I had to do those kiss me back. I just need that. Awesome stuff, please.
Where do you go?
Well, I got the knife one, so Tyler.
Have a good day, everybody.
I need to play something. I played in the hall.
Mask it up.
Like, I don't want to get murdered. First, they got murdered. So that's literally how it goes.
My brother will literally throw a fit if he doesn't get to have it. It's fine, and I paid for what I'm gonna take this back.
Homework from last night that we went over, I got everything right except I got everything right except the estimate.
Wait, no. It is. She cries about everything. Yeah. You do. You do. You cry. You get smell like. Yeah, you do. If somebody asks you to do something, you're like, no. Okay, update. I know, one of my screenshots disappeared. It shows a warning sign. I got it done in class.
You didn't get anything good.
Did you get it done?
Not even one problem.
I got that done.
Yeah, I'm getting a good person. You getting a good person for sure.
You should be working on your math minute at this time. Your assignment should be out ready for me. And it should be ready. Oh. Sorry, your writing work, I'm not gonna mark it because we still, if you have anything that's graded, I can mark on there, but a lot of it can be still turned in today. So, if it needs to be turned in, get it turned in. It's already graded, I can put it on there, but a lot of it has to be turned in today. You have to do four. Okay, turn that into the tray, please. And then let me, before you go, let me see your 4 problems. Okay, Israel, have your 4 problems ready for me, so you can quickly click on them. Did you turn your on? Your eye ready? Did you turn your eye ready in from last week? Deleted one of them? Huh? You didn't do any of it? Okay, let's do tonight. Give us your attention. You what? Do what? Not right now, no. Let me get that finished. Get your butt up. Yes, repeat him also, please. That's good. You guys told her I didn't get to. Shouldn't have to tell you that almost every day. ahead, take a look at our answers to our math minute, please. Number one, what is the greatest number? Thing. 1600s. 1 of 1600s. What happened there? Number one, the second largest number. Just 6/10. 6/10. We didn't have to add the 0 to it. The third one. 1600s. And the smallest one came last. Smallest one came last. Isaiah. Isaiah.